Welcome back to the physics talk show that matters. I'm your host, Dr. Samuel Gaskin. Today we got a special fan request to talk about Paul Dirac, the famous physicist. If you guys want to hear something on our show, let us know, tweet about us, and we'll make it happen. So let's get down to the nitty-gritty. You guys know how this works. We have some rapid-fire information and then a joke, and we perpetuate this throughout the show. So first of all, Paul Dirac. He was born in 1902 in Bristol, England. Although he was technically Swiss until 1919. That's because his father was a Swiss immigrant and worked at a French school in Bristol, England. His mother was a librarian in Bristol, England, and he had a younger sister and an older brother. Unfortunately, his older brother committed suicide when he was in his early 20s. In addition, he had some strained relationships with his father. This is because his father was a very strict man and made him only speak French to his father, although he never learned how to speak French. And Paul Dirac thought to himself, if he couldn't express himself exactly how he wanted because he had to speak French, then he chose to not speak at all, and he became very introverted because of this. Paul Dirac had a wife named Margaret Wagner, and they had 2 adopted children. He spent most of his time doing research, and his wife basically took care of the bills, took care of the children, and everything else in his life. He had an electrical engineering undergraduate degree from the University of Bristol and a PhD in quantum physics from the University of Cambridge. He also produced many more theses, many more inventions, and had many more theories in physics, which we will get on about later on in the show. One of his most famous and honored prizes is the Nobel Prize of Physics, which he was awarded along with Schrödinger in 1933. He was known as a very modest guy and didn't speak very much and was an introvert, and some of his colleagues jokingly made a unit that was actually pretty popular called the Dirac unit. And 1 Dirac was 1 word per hour. And this is because Paul Dirac was known to speak very little, and his vocabulary consisted of just yes, no, or I'm not sure. And because he spoke so little, they created the Dirac unit and would sometimes count how many Diracs he would speak per day or something like that. So now we're on to the first joke of the day. Man, I love jokes. So next, Dirac invented many general theories of quantum mechanics and had many field theories. He created the Dirac and Fermi statistics. So this statistics talks about the distribution of particles over energy states in systems of many identical particles that all follow the Pauli exclusion principle. He also created the Dirac equation. Now this was huge for him and was partly the reason why he was awarded the Nobel Prize of Physics. We'll talk about this later on in the show. In addition, he had a theory of magnetic monopoles, and I know what you're thinking, like, there's no way, those don't exist even today. And he had the theory 100 years ago, and that is true. He believed that a single magnetic monopole in the universe would suffice to explain the quantization of electrical charge, and now you're thinking about it and like, yeah, that makes sense, but there's still no concrete evidence that monopoles exist. Next is joke number 2. Was that a good joke or what? Next we'll be talking about the Dirac equation, created by none other than, you guessed it, Paul Dirac. So this equation combined the quantum theory with special relativity to describe the behavior of an electron at relativistic speeds. So the quantum theory, or quantum mechanics, is basically talking about nature at the subatomic level and the wave-particle duality of nature. And the special relativity has 2 main laws along with many other things, but these 2 laws are that the laws of physics are invariant and the speed of light in the vacuum is the same for all observers. So he combined these kind of 2 theories to create his equation. One really cool thing about his equation was that it defied common sense of the time. So common sense would say that energy can only be positive or zero, but his equation showed that electrons could have positive energy and negative energy, and the negative energy worked in his equation just like electrons with positive energy. So to simplify this, it's seen as like how x squared is equal to 4, but x can be 2 or negative 2. There's 2 answers. Just like in his equation, you could have positive and negative answers. So this led him to the theory and creation of antimatter. And basically, he thought that there was the same amount of antimatter in the universe as matter. That'd be cool, wouldn't it? Maybe somewhere in a parallel universe there's a physics talk show that antimatters. Man, that'd be cool. I want to meet those guys. But anyways, Antimatter wasn't first seen until 1932, which is 4 years after he created this equation, and then he won the Nobel Prize for Physics in 1933 because of this validation of antimatter. Basically, whenever antimatter comes into contact with regular matter, they are complete opposites, so they both annihilate and turn into energy. And because we have such an abundant supply of matter, it's very difficult to observe or see or contain antimatter in any way. And he observed this in 1928. This theory, describing the behavior of these electrons and positrons, has been very helpful to the work of quantum mechanics by the next generations of physicists. Now, we'll go on to the next joke. Next, we'll be talking about the impact of the Dirac equation on society and the economy. So, the Dirac equation shed some light on the lead-acid battery confusion of the time. And this is because lead and tin have very similar properties on a large scale, and people were so confused as to why tin would not make a good rechargeable battery, but a lead-acid battery was very good and was still used today. And this was all cleared up through the Dirac equation. And this is because one can see that through the Dirac equation, tin has no relativistic effects unlike lead. And that's why lead is a very effective lead-acid battery, where tin doesn't make a very effective tin-acid battery. Another thing Dirac proposed through the Dirac equation was the creation of antimatter. And antimatter is still used in the world today. And you can see this through CERN research facility and other research facilities around the world that use antimatter and find antimatter and study the behavior of it to further our understanding of the laws of nature and different laws of nature and different laws in physics. And last, the applications of antimatter are endless. One of the most influential ones that is very important for the economy and for our health would be PET scans. The P in PET scan stands for positron, which is the antimatter or an anti-electron. And what PET scans are is when they shoot positrons at someone's brain, and then they come in contact with the electrons on the brain and create gamma radiation. And this gamma radiation pattern can be seen on a screen, so doctors can see what someone's brain looks like and tell them if they have a healthy brain and if they don't have a healthy brain. And this can save people so much time, money on different medical expenses, and even save someone's life. And that's just huge for society. So next we'll go on to the next joke. What's going on, everyone? You're probably wondering why I'm in the washroom right now. And it's actually because I just created some antimatter in my studio, and it combined with some matter, and upon annihilation it created gamma radiation. I know, mind-blowing. But this radiation may be harmful for myself, others, and the environment, and that's one of the negative effects of antimatter, but it should be all cleaned up shortly, and we'll be back to the studio as soon as possible. We're on to the next joke, everyone. These jokes are just so cheesy now. But we're back with the physics talk show that matters. Now, Paul Dirac was influenced by his family and his surroundings and made him into the physicist that he was. So one thing was that he had a strained relationship with his father that I explained earlier on in this show, and he became okay with not talking to others for long periods of times, and he became very introverted. Because of this, he was okay spending many days, many nights alone doing research. And he was able to do so much research because he was okay as an introvert, and he was developed throughout his family as an introvert. In addition, his wife was so supporting of him and took care of his children, his housing, his money, everything in his life but his research, so he could just spend all his time or as much time as he wanted doing research. I hope my future wife is like that and lets me just focus all my time on research, because that's my dream, becoming a physicist. In addition, he finished his electrical engineering undergraduate degree during the post-war depression. So he was unable to find work as an electrical engineer, so he was able to go back to school for a few years because he had nothing else to do. And then he got a scholarship and enough money to go study at Cambridge to produce his quantum mechanic theses. And that really started the tipping point of his career. So maybe if he wasn't trying to find work during the post-war depression, he would have found work and would have never become the physicist he became. And last, he did a lot of experiments using uranium and a lot of research with uranium because there was such an abundant supply of it during World War II, and that's when he did most of his research because that's when he was alive. So with those in mind, those are some of the most influential factors that made him into the physicist that he became. We're on to the next joke. Hope it's not as cheesy as the last one. That was a better joke. Now, Paul Dirac, although he was very influential, very famous, he was still overshadowed a little, and this is because he was so modest. So for one, he created something called the Dirac statistics at the same time as another guy created the Fermi statistics, so they combined them and called the Fermi-Dirac statistics. But whenever Dirac would lecture, he would just call these statistics the Fermi statistics and gave Fermi all the credit for this. And then people thought just Fermi created this, so he got overshadowed by Fermi. And in addition, he created an equation for time evolution, but he would call this the Heisenberg equation, even though he wrote down the equation before Heisenberg, and he gave Heisenberg all the credit for this. And last, the Dirac equation was also independently discovered by others at a similar time, named like Wolfgang Pauli, and it was very similar to an equation by Klein-Gordon. So in other parts of the world, they don't really give Dirac the same respect as we do, and that is because they look at he gets overshadowed by some people like Wolfgang Pauli on his Dirac equation, or the Fermi statistics that he actually independently created at the same time, and so he's overshadowed by these others. But we're going to the next joke, folks. Okay, that's all for today, folks, but I'll leave you with one more fun fact of Paul Dirac, and this is about his religion. So when he was in his early 20s, he really didn't believe in God or in a higher power at all, and he thought that it was just a way of the higher class of keeping the lower class in check, believing what they were doing is what they're supposed to be doing. But later on in life, he started really believing in a higher power and in God. And this was because throughout more research and different theories he created, he was able to see the symmetry and the complexity of math and physics in nature, and he thought to himself that there was no way that was random, and that had to be created, this complexity in nature had to be created for a higher power, and that's made him start believing in a higher power and in God. So I'll leave you with that, folks, and see you next time on the Physics Talk Show that matters.